Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America. Oh my God. Yeah, sorry, I've been battling a cough for weeks now, but everyone, welcome into the program. Excuse that. I hope that you're all doing well and you're ready for the program. We are the nation's longest running, nationally syndicated radio talk show on computers and technology for, for how long has it been? 91, February 91. Wow. Craig started the show. Yeah, long time. So yeah, that brings us up to almost 31, almost 32 years. Everyone, welcome into the program. We've turned podcast and we've enjoyed the format ever since. We hope that you have too. And we have a great show planned for you today with Ralph Bond. He is, of course, a longtime correspondent and our science and technology trends correspondent. He'll be joining us here in just a moment with 4 amazing stories that, hey, for a Friday, you want something a little uplifting, good, something that, and I'll talk about this with Ralph because there was another headline just yesterday that also brought some good news because, there's a lot of bad, and I think some of it has to do with politics, some of it has to do with reality, and some of it has to do with, hey, it's just what gets clicks. But ladies and gentlemen, we try to be uplifting here, and it's going to be a lot of fun, and Ralph always delivers. So before we get started, computeramerica.com, that's where you'll find everything, including the show notes, past shows, future shows, podcasts, archives, video, social media links, contests, giveaways, all that and more. Computeramerica.com is the best place to find everything that we do, and please give us a like, give us a follow, and keep up to date with what we're doing. Now, with that being said, let's go ahead, bring Ralph on, and just have a good show. So, ladies and gentlemen, once again, Ralph Bond, a science and technology trends correspondent, and always a pleasure to have on. Ralph, welcome back onto the program. How you doing?
I'm doing great, Ben. Great to be back. And you're right. We're going to give some uplifting news in an otherwise dark and scary world anyway. But great to be back. And today we have 3 climate change related stories. And then at the end, one about a fascinating Hyperloop-like train project that's proposed for Canada, where these trains would go faster than a commercial jet. So we'll get into that at the very end.
Perfect. Yeah. And, we'll get into, kind of what your mission is here on the program. But first, I want to say happy Halloween. By the time it rolls around, we'll meet here next Friday. But, Ralph, I got to say, when I was a kid, and I still am, but I don't get to trick or treat anymore. When I was younger, I always hated when Halloween landed on a school night. Friday, Saturday, maybe even Sunday night were always the best. Monday night, I feel bad for everyone this year.
Yes, yeah, that's always tough on the parents too, by the way.
yeah, for sure. And I grew up with with a single mom most of my life until Craig showed up. But she always had to stay home, and we got to go out when we were 10, 11, 12. I like to think that kids could still do that. I honestly do not know if 10-year-olds, especially in a group, could go out alone and trick or treat. Yeah. But I don't know.
Yeah. So far in our area where we live, it's still quote unquote safe, but these days, Lordy, you have to worry. But anyway, that's a downer. We're not doing downers.
No. Happy Halloween. That was the point of that. And everyone, I hope that you're going to have fun. So with that being said, Ralph, let's go ahead and introduce the news folks, what it is that you try to do when you come on the program.
Sure. For first-time listeners and viewers, I'm an aggregator of science and tech news features I find by monitoring a host of online news outlets all the time, all day long. I look for important stories that don't usually capture mainstream press attention. Some do, but most of them don't. And sometimes they're kind of out there, wild stories and kind of fun and wacky science stuff, wacky tech. I'm always on the lookout for news that gives a glimpse into where we're headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it. And what I do with each news item And what I do really together with Ben is present the essential points in a hopefully very digestible, humanized form. And I stress to our audience, as Ben did too, please come out to computeramerica.com, get what we call the show notes for today's show. That's sort of the script of what I'm going to be sharing with everybody today. It has links and pictures and all this sort of stuff, because one thing that both Ben and I want to stress is that we're just going to give you the highlights. If you want to dive deeper into the technology or science of every story, that's what you need the links for. Come on out to computeramerica.com and get the show notes.
For sure, for sure. So, and we'll have that by the time, obviously, the podcast is up and all that good stuff. Now, Ralph, if you'd like, we can go ahead and start with story number 1.
Yeah, story number 1 from the Smithsonian Magazine. And this was very personal for me. Climate change. You are messing my life up if you're going to mess up my wine grapes. To make wine, you go after my wine, and you're in trouble, buddy. Okay, so headline here. Scientists are developing new hybrid grapes to help wine industry adapt to the effects of climate change. And maybe your audience may or may not be aware of this, but Oregon and Washington State, along with California, huge wine industries here. Huge. Mm-hmm. And so this is not only important to me personally as a wine drinker, but also as a citizen of Oregon, where the winemaking industry is a big part of our agribusiness economy. So with that said, let's get into the story. So Ben, probably a lot of this won't be a surprise, but here's the problem that the wine industry is facing. Rising temperatures due to climate change are causing grapes to ripen faster. And also this allows bugs and diseases to thrive. And then add to that, and this is particularly important for us in the Northwest, as your reviewers and listeners may know, I live in the Portland, Oregon area, but increasingly frequent and more intense wildfires are causing smoke damage on the vines, which is really bad.
I guess wine drinkers aren't really known for enjoying that smoky flavor in their wine. It's probably more of like a whiskey thing. Right?
Yeah, that'd be more like a whiskey thing. Good one. And then excessive drought. Oh, great. Excessive drought puts too much stress on the vines. That's more a problem for our friends in California, which results in lower yields. And then add changes to rainfall patterns coupled with higher temperatures are leading to increased levels of humidity, which in turn allow mildew, molds, and diseases to overwhelm the vines. So all that sounds terrible, and it is. But drum roll, please, to give grapes a fighting chance going on in the future that we are facing here. Researchers at the University of Minnesota, Cornell University, and the University of California, Davis, an interesting team. When you think about this, has to do with wine and wine grapes and so forth. What surprised me was University of Minnesota and Cornell. Now, Davis, University of California, Davis, California, of course, wine, that makes sense to me. I would love to know the backstory of how this coalition with University of Minnesota, Cornell, and University of California, Davis came about. But what this team is doing, they're using genetics to help create hybrid grapes by crossing European species of grapes with our native North American grapes. And this was news to me. Our native North American grapes offer cold hardiness and disease resistance. And then what they're doing is they're selecting for specific preferred traits based on their genetic research, which is kind of interesting. And Ben, this goes back to something you and I have been talking about for the last, pretty much this entire year. Genetics. We used to do so many stories, and we still will, about artificial intelligence, of course. But genetics has just bubbled up in the radar sweep of the stories that I see over and over again. And this is another example. So the research team in question is now using DNA testing to understand where desirable traits come from in the grape genome, so they can select for those traits earlier in the breeding process. And remember, folks, that a genome refers to all the genetic information of an organism. So that's what they mean by genome. And here's the good news. Now we have good news. The DNA analysis effort from this team is already identifying the parent grapes that carry the genes researchers are interested in, which is allowing them to choose the right varieties to pair up. So stay tuned. And my friend Mark Mason at KEX Radio, we did this story today as well. he said, wow, I wonder what that's going to do in terms of the types of wines, flavors of wines. We're so used to Merlot and Cabernet Sauvignon and all this sort of stuff. Well, what's going to happen if we start crossbreeding and coming up with these new wines? So there may be a whole future of new wines on the horizon, but at least we'll still have wine. And that's the most important thing.
Yes, and at least we'll still have a supply. And I'm not the biggest wine drinker, but I know that there are certain regions especially in France, and I'm sure in California as well, Sonoma Valley,
yes.
that if they're kind of like prized for the flavor of the wine, and there are some sommeliers and some people that can do the thing where they smell it and then taste it and they're like, yes, this is a 2003 from the so and so region.
I know
that kind of thing. It seems like that's not going to be as reliable anymore because the subtleness of the wine, and some people get really crazy with it. But Ralph, it sounds like that's all going to change, and I'm not going to say it for the worst because change doesn't always have to be bad, but that I guess the wine that you could rely on is not always going to be year over year the same wine. So could be different, could be good.
Well,
you never know.
There you go. Like I say, thanks climate change. But again, at least there's a future for the wine industry. If we of humans don't get our act together and solve this climate change problem, at least our wine will still be with us.
Yes, we'll still have a supply. So it's very, very cool though that even though there are problems, I think mitigating those problems is just as important. And hey, we often talk about replacing jobs and things like that. This is actually saving jobs, letting farmers do their thing by technology advancement. So
absolutely.
Perfect.
That's a good point about the job part, and that goes back to what I was saying about the importance of winemaking to the industry of the West Coast and elsewhere in our country, and then Europe, as you mentioned, and South America too. Remember, and so many parts of the world where winemaking is a huge part of their economy. And
everyone can keep doing their thing. This is perfect. Yeah. So that's story number one. Story number two, and we often talk about carbon mitigation, how to reduce our footprint and reduce and reuse and that whole thing. But one part of the equation that is much harder to do is, of course, just sucking the carbon out of the air, because we're really good at putting it in there, but what about pulling it out? And Ralph, we've done a lot of stories about possible answers. None have really been scalable or anything like that, but hey, story number two could be another contender.
Yeah, this one really caught my eye. And story number three is related to story number two, a little preview here. But here's the headline for story number two. The world's largest carbon removal project is headed for Wyoming. World's largest carbon removal project going into Wyoming. This is pretty cool. Mm-hmm. Got this from The Verge, theverge.com, great outlet, by the way. So here we go. Plans are in the works to build a facility in Wyoming that will ultimately be capable of extracting 5 million metric tons of carbon dioxide out of the atmosphere annually by 2030. That's the ultimate goal. It won't be that at the beginning, but ultimately it will. And again, by 2030. And the CO2 captured above ground will then be stored deep within the earth. And this is where having the show notes on your screen right now would be helpful. Yeah. Because you can see the picture of the aerial view of this proposed layout that they have in mind. So here's what's going on. A Los Angeles-based company called Carbon Capture, they run those two words together, Carbon Capture, is building the facility, which they call Project Bison, very appropriate for Wyoming, which is expected to start operations as early as next year. So this is coming. This is not a fantasy. Mm-hmm. Carbon Capture's plans call for the use of modular 40-foot box-like above-ground modules that look like shipping containers, if you look at the photo in the show notes, with vents that air passes through. And inside each of the modules are 16 reactors with sorbent, that's SORBENT, sorbent cartridges that essentially act as filters that attract the CO2 or carbon dioxide. Now, what are sorbent cartridges? I had to find out. Mm-hmm. Solid sorbents for carbon capture include a diverse range of porous, solid phase materials, including mesoporous silicas, zeolites, and metal organic frameworks. And that's a lot of, techno gobbledygook there. But these have the potential to function as more efficient alternatives to amine gas treating processes. And all of this is something I don't profess to have an expertise on. You can dig deeper in the website of carbon capture and other sources to learn more about this. But bottom line is these sorbent cartridges can remove CO2 from large stationary sources, including power stations, et cetera, et cetera. The link here in the show notes for this is Wikipedia. You can check this out and dive deeper if you wish to, but that's the bottom line. It's like a big kind of sponge, relative to extracting the CO2 out of the air. So these sorbent cartridges that carbon capture is created and planned to put into this Wyoming site can capture about 75% of the CO2 from the air that passes over them. And within about 30 to 40 minutes, the filters have absorbed all the CO2 they can. Now, once the filters are fully saturated, the reactor goes offline so the filters can be heated up to separate out the CO2. Wow. There are many reactors within one module, each running at its own pace so that they're constantly collecting CO2. So it's sort of like a tag team kind of deal. Together, they generate concentrated streams of CO2 that then can be compressed and sent straight to underground wells for storage. And as the carbon capture equipment is modular, again, look at the picture in the show notes, the company says they will make it easy to scale up. To your point earlier, Ben, this is a scalable solution. And according to carbon capture, the project will start small and work up to 5 million metric tons a year. If all goes smoothly by 2030, the operation will be orders of magnitude larger than existing direct air capture projects around the world. So again, ultimately, it will be the world's largest facility. And I'm so glad you're showing the video here. Right. It gives you an idea of what this and the size of these units and the modularity of them and the scalability accordingly. Now, my friend, again, Mark Mason, host of the Mark Mason Show on KEX Radio here in Portland yesterday, said to me, "Hey, this is cool, Ralph, but what happens when, the underground wells or the underground cavities are full of the carbon CO2? What do we do then?" I said, "Well, I guess at some point you're just going to have to move on and build some more of these guys someplace else." I guess that's how it is. But that does give us a nice segue into story number 3. But yeah.
Right. Yeah. There's a lot more underground than there is. And I know it sounds weird, but like the mantle and the crust are pretty thick, and there's a lot more underground than there is sky. So I don't think we really have to worry too much about places to kind of store this underground.
Good.
But also I have so many questions for this, and so I like to be uplifting, but I'm so incredulous because this is a company selling carbon credits, and carbon credits are kind of shaky and iffy at that. Obviously, you need some way to pay for this, and sucking carbon out of the air is not exactly yes, it's useful for living, but economically speaking, you don't really make a lot of money saving the world. It's just not that profitable. So carbon capture credits, that's a great topic, and I'm glad you brought it up in here because that's maybe the little bit of the disappointing part of the story, I guess you could say. But here's something interesting. Here in Oregon, and maybe elsewhere in the United States too, I'm sure this is not unique, but we got a flyer in the mail, and it said, "Hey, guess what, folks? If you have big trees on your property, you can cut a deal to do carbon capture credits and get paid." What? And I started researching this, and that's how I learned about what you're referring to. And my wife and I said, "Well, yeah, it'd be nice to get a few bucks a month because we have ridiculously big trees on our property." Right.
But I said, my wife and I looked at each other and we said, "Well, you know what? What we'd be doing is rewarding these big companies for not doing the right thing." And they get this say, "Well, we bought these carbon credits. Somebody else is doing the dirty work, so to speak, and we're off the hook. So don't bother me with trying to clean up my act as a factory or whatever." And we thought, no, we're not going to support that. So
Yeah,
double-edged
carbon
sword.
credits are kind of those things that you can buy. You can buy the rights to trees, forests, entire plots of land, and be like, we supported this ecosystem. But Ralph, just like you said, though the trees in your yard, they're already doing their thing. They're already being trees,
right?
By selling them as carbon credits, you're just allowing companies to not touch your trees in any in any manner, and they also don't have to find a way to mitigate their own mess that they're making. Carbon credits are hugely controversial, and I don't know if you know Last Week Tonight with John Oliver, Ralph. I don't know if you're.
I know that. I know of it.
He did a great segment on carbon credits and really just how unregulated that market is. So everyone, a little bit of homework. He's very funny, and of course his writers are great. But this idea though, as a whole, giant filter sitting in the middle of nowhere, seems like it needs minimal investment to kind of get these things up and going. I would, and by the way, any project that finds a use for Wyoming, amazing, perfect. That is a great thing. Wyoming has sat there useless for long enough, but for everyone else, and that was a joke. I said a very straight face. So, anyways, no offense to anyone in Wyoming. I hope, Ralph, they can put these things, right outside of cities, in places a bit more useful. Because I know you could say, the whole holistic, it's one atmosphere, that kind of thing. Ralph, if you could build these things outside of major cities and maybe, scrub the air from more polluted population centers, that seems like another great use for this as well, not just in the middle of nowhere, because I think Wyoming actually has pretty good air quality. They're probably pretty good. So maybe outside California.
That's a really interesting point about putting it in an area where probably, as you say, they have a remarkably, generally speaking, good air quality. So I don't know, there's a lot more, it raises a lot more questions than we have answers for right now. But at least it's an interesting set. And I think your point's well made. This technology, maybe in Wyoming where the air quality is super great, maybe that's a little, less compelling, but take this technology and put it into an environment where there are terrible air quality challenges. Could be interesting. And I also thought, whilst you were speaking, what if you had a flotilla of these things out in the middle of the Pacific or out in the ocean or whatever, where there won't be in the way of the shipping lines, but they could just be sitting out there doing their thing, right?
Yeah,
so and like
they're like, clearly we need a lot of these things. Like to make any kind of noticeable measure, we would need a ton of these things. And an idea like this is definitely welcome. It's just, the economics of it and the placement of them, that we can argue all day on, but the need for them, 100%. So I'm glad that someone has a good idea. And honestly, for everyone who has simply been listening to us, these things are about the size of a tractor trailer, that you see driving down the highway. They are modular in exactly that format. So you can haul these things and move them easily. So very good idea. And again, the video was a lot of fun to watch. Ladies and gentlemen, story number 2. Ralph, you said story number 3 is very or at least similar in, theme.
Closely related. So story number 3, the headline here is Northwest scientists are working to see if they can convert carbon dioxide pumped underground into stable minerals. So remember the story we just did, they capture that CO2, they compress it, convert it, and store it underground. But these scientists are working on a follow-on to this, and this comes from the Pacific Northwest National Laboratory in the state of Washington. So it's just up the road from where I am. These guys are amazing. I've kind of gotten onto these guys just this year. I'm embarrassed to say they've been around for years. They're doing some amazing stuff, but I digress. Here, let's get into the story. So as we just talked about, of course, capturing CO2 from the air and then pumping it into the ground will help fight global warming. But what if it leaks out? That was the big question these scientists asked themselves. So to prevent this from happening, the scientists at the Pacific Northwest National Laboratory in Richland, Washington, are exploring how carbon dioxide pumped into the ground can be converted from a gas to a solid minerals or to solid minerals by using an experimental process that takes advantage of ultra thin films of water on underground rock surfaces. Now I'm going to do a quick timeout. This is where I stressed before, if you want to understand more about this process, go to the show notes, get the link, dive into the article, because we don't have time to get into all of these steps and procedures that are involved with this. But it's this clever thing of taking advantage of these thin films of water on the rock surfaces underground and creating a reaction. But anyway, if successful, the end result would be stable and common solid minerals called carbonites that would ensure the captured carbon dioxide stays underground. It's sort of like an insurance policy, right? Mm-hmm. And understanding how and when these carbonites form requires a combination of laboratory experiments and theoretical modeling studies on computers, of course. Knowing how CO2 will react with different minerals can help make sure that what gets pumped underneath the surface of the ground or earth here, it stays there, it stays put, right? And right now, this isn't just all a pipe dream. Right now, at the team's Basalt pilot project in eastern Washington, kind of a remote area, they are working to fully understand how this carbon dioxide to solid minerals conversion process operates before they can predict and control carbonate formation and, in turn, ultimately create plans for realistic and cost-effective systems that could be deployable in the real world, where these sort of facilities like the one we just talked about that's going into Wyoming are being created. So it's kind of cool. So again, this is key research to monitor, as it could help make capturing and storing carbon dioxide underground a safe and viable tool in the arsenal of ways to fight global warming. So it's sort of, again, like an insurance policy technology, if you will.
Right. Yeah. It's a way to say that, it's not just pumping it randomly underground and be like, oh, it's rocks. Nothing escapes from rocks. No, it's actually pumping it into material that will actually contain it and, kind of keep it from, I'm sure, leaking into water tables and things like that.
Ooh, good point. Good point.
Very, very, very useful. And, just make sure that, hey, what we're doing is actually helping, not hurting in a completely different way. So there's a lot of and like it just goes to show that you think that the hard part is capturing the carbon out of the air, and then you have a bunch of waste and you just pump it underground. No, there are entire teams working on what happens after we're done with it. What happens after we thought we have solved the problem. Right. And great research. So I'm glad that they're thinking about that as well, because I know I certainly didn't. So there you go. Story number 3, and everything that we said about story number 2 applies to story number 3 as well.
Yep.
So story number 4, he said this one we're getting a little bit away from the atmosphere and that whole thing, and getting a little bit different to hey, actually. This sounds similar to a story that we did a couple of weeks ago about airplanes and this is a little bit different, but anyways. Trying to make planes more efficient is a tough task. And we've talked about, electric powered planes and biofuels and different kinds of things. But everyone's looking, Ralph, for a better way to move cargo, people, whatever. Story number 4 might have an answer that looks a little bit like, Ralph, what was it called? The Hyperloop.
Yes, idea. The Hyperloop. You're absolutely right. Yeah. So, friends, if you're familiar with Elon Musk's vision and research and work for something called the Hyperloop, which would be his super high speed train, if you will, that's very closely related to this story. So here's the headline. There's a Canadian company that wants to build a train plane hybrid that can go 620 miles per hour. Wow. Got this from CNBC. Also, I did additional research on futurism.com. The show notes have the links to both of those resources. And the image there shows this tube with the train module on pylons going over a landscape and so forth. It's very sexy, very cool looking thing. And there's a video here that Ben is showing you right now. So here's the story. A Toronto-based company called Transpod, that's TRANSPOD, run together, Transpod, recently unveiled plans for a fully electric transportation system, which they call FluxJet, that's FLUXJET, and that it looks like, if you look at the picture, it looks like a hybrid between a wingless jet aircraft fuselage and a train. And the project, currently in the conceptual stage, would involve 82-foot long, magnetically levitated, zero emissions trains that would carry passengers at roughly 620 miles per hour. Now, that's faster than the average
Yeah.
commercial jet. That blows my mind. Faster than the average commercial jet, and roughly 3 times the speed of most high-speed trains on the planet today. And the levitating train's aerodynamic design, no surprise, is meant to reduce friction. And the Flux jet's theoretical ability to outpace jets and high-speed trains rests on technology influenced by Valiance, and I hope I'm pronouncing this right, Valiance Flux, that's Veillance, and then the word flux, a relatively new field of physics. And, okay, time out. Valiance Flux has to do with valiometrics. And I've got in the show notes some really super geeky get down on this thing. But it all has to do with the measurement of measuring sensing. It's a quantified approach to the sensing of sensing itself. Okay, this gets really weird. It's super weird. I'm not even going to try to get into it, but in the show notes, I have a link for you, a really good paper from the University of Toronto. You can learn more about this if you want to. But when traveling between stations, the aerodynamic levitating train will, quote unquote, fly. That's where they get this kind of train plane notion through elevated, above ground, transparent, vacuum sealed tubes supported by pylons, as shown in the image in the show notes, somewhat, and here it goes, Ben, somewhat kind of sort of like the Hyperloop train concept popularized by Elon Musk. And for power, the Flux jet train would rely on contactless power transmission, where the train would pull power from the existing electric grid through magnetic fields. And you know what, Ben? I thought to myself just the other day, I thought, hey, is this sort of like, I have one of those deals where I can put my iPhone on a little tray. I don't have to connect it with a wire. It just gets recharged.
Magnetic induction.
Yeah, that's the same principle, I would assume.
Yes.
I think, right?
Yes.
Isn't that cool?
And for everyone just watching the video, and I can't rewind the video, but the website itself has a nice little video that seems to be going on for about 5 minutes that explains every little part of this. Admittedly, it's all kind of hypothetical. It's not in actual practice, but they do a pretty good job of explaining every and now they're explaining the valence part of this.
Yeah.
But it's a very interesting concept all around.
Yeah, I think so too. Yeah. And then to start, so this is where, if this works out, I mean, this is going from theory to practice, right? So that's why I really like this story. If it was just theoretical, just research, I still would have reported on it. But stay tuned. To start, the company plans to build a nearly 200-mile vacuum tube network between the Canadian cities of Edmonton and Calgary. And by the way, I didn't get this in the show notes, but they estimate if they complete this system, which they fully intend to do, it would take about 45 minutes to do that 200-mile trip. And when the system is fully operational, Transpod estimates the cost for passengers for a ticket will be 44% less than the cost of a comparable plane ticket if you were to fly between those two destinations. So they're planning to make this a reality, which is will be really, if they pull this off and if it works and if it's safe and all that good stuff, this could utterly transform. Can you imagine having something like a San Francisco to New York, or having, you could have a network just like our current aircraft industry is, right? Our current airports, you could have these train systems from, Los Angeles to Kansas City or whatever, and then branch out, right to Atlanta. All the same thing could be just replicated with these trains. Oh, wow.
Yeah.
I mean, it's just like mind blowing.
And I guess the other half of this equation, and for those who are looking at it, it's essentially two tubes and, kind of this, something that looks like one of those highway overpasses with the pylons that hold up the highway. Very similar, kind of scheme, but it looks like that's what they'd kind of create in modularity, and then they would kind of connect them together one by one. So they're saying that the infrastructure to create this is much more scalable than previous ideas, and we can certainly hope for that, Ralph. And I remember thinking about this with the Hyperloop and saying it on the show, but for those who don't recall all of my words, which, ladies and gentlemen, remember everything I say. Ralph, it has to do with, like, when you're traveling at 600 miles an hour and it costs, the price of, maybe not even a plane ticket, but even cheaper than that, hopefully, Ralph, imagine that you could have, when going from, let's say, Boulder, Colorado to Austin, Texas takes you about 30 minutes, because you can go 600 miles an hour, or, whatever the math works out to. My point is,
right,
you could go there for lunch. You could go there for, for the weekend very, very easily. It becomes so quick, so almost like instantaneous that the world gets kind of smaller. Ralph, if you wanted to go from New York to, Boston, and it takes 10 minutes by this thing, the world becomes much more accessible, and that's an exciting idea.
Yeah, and another thing I was thinking about too, and it actually my friend Mark Mason at KEX Radio here in Portland brought this up, and if you look at the imagery of the train module, if you want to call it that, it doesn't have windows for the passengers. And at first I thought that's kind of creepy, but then again, think about that. If you're going 620 miles an hour above the ground, not too far off the ground, it probably would be freaky. I mean, it would just be so weird. You'd be going so fast that you might get motion sickness or whatever. So I thought to myself, well, there's not going to be windows in this thing. What if everybody was provided with virtual reality goggles? Yeah, and you could have a beautiful, lovely, carriage ride down a country road or something as you're going 620 miles an hour, or whatever you want. Maybe you have a whole menu of things you could just look at, or just other screens or entertainment or whatever the case may be, to keep your mind, focused on something other than realizing you're going 620 miles an hour in a tube.
I think that Windows would be, a little meaning, because in my mind, I'm thinking kind of like the subway system in New York or something like that. Not a lot to look at out there. And while there might be stuff to look at here, I guess the need for completely vacuum tight, windows would be kind of a extra cost that doesn't really have a lot of benefit. I'm thinking like those big LED walls that you see at maybe malls for advertising, stuff like that. Just coat the walls with those, and throw up advertising or scenic views or whatever you want to do to help pay for the thing. This whole idea, though, is Ralph, it's cool to know that we had this idea a couple years ago, and a couple of billionaires couldn't really get it off the ground, but the idea is not dead. Other companies are coming up saying, hey, we think we can do this. That is, that's a good step in the right direction. So very, very good. I think so too. Ladies and gentlemen, we're done with our 4 stories. And again, check out the show notes. We're going to have links to everything. I wanted to bring one more story to everyone's attention, Ralph. And this has to do with, this is from the New York Times, and they just ran this 2 days ago on October 26th about beyond catastrophe, a new climate reality is coming into view, and it's essentially saying that they're saying that in the past 5 years, humanity has cut expected global warming almost in half. So that means that, from 5 years ago, it wasn't really on anyone's radar. Like, don't get me wrong, people have been fighting the climate change fight for 100 years, but it wasn't really policy up until, maybe a decade or two ago. Ever since those giant hurricanes started slamming into places, and wildfires and earthquakes and things like that. But anyways, my point is, Ralph, now that it's, more of like more present in a lot of people's minds, from doing almost nothing to taking the steps that we have already taken, we have cut the expected global warming in half in just 5 years. So not saying that we're cured, it's done, we can go back to polluting as we want, just saying that the steps that we're taking are having a measurable effect. So it's not all doom and gloom. Good. Changes do have an effect, and hey, Ralph, some of those are going into practice. It's we're not all dead. Everyone, it's going to be okay. But hey, technology, I've always felt, is going to get us from point A to point B, and technology has a lot of greatness to it. So Ralph, I want to thank you so much for coming on the show once again. And ladies and gentlemen, we hope that you had fun. Once again, have a great holiday. Have a great Halloween. I know it's on a Monday, but it's going to be fun. Have a great weekend. Ralph, thank you so much for coming back on the program and sharing with us these stories. You can check us out again next Friday. Every Friday, Ralph comes to us with a ton of different stories. And hey, could be construction, could be environmental, could be genetics, and I was about to say genomics, but I think that's a study of gnomes. Probably not what we cover. So, ladies and gentlemen, thank you so much for tuning in to the program. We'll catch you here next time. Everyone, bye-bye.